This is a video about my task detection and recognition project. First, I will introduce the breakdown of my project directory. First, the gift result images and GIF task output contains the output of GIF task detection. Then, the GIFs and images contains the files that are related to doing the task detection and recognition. Then, this model's directory contains only one model, the east task detection. And the results images directory contains the results after processing and detection. For this SRC directory, it contains the main source code. For the last one, test output, it is a directory that contains the test result, and they are the TST file. So next is my project demonstration. First, let's look at the photo test main.py file. This is the file that performs static image test detection and recognition. In this file, I use the flag lock mechanism to prevent resource competition. And the runIsFlag function will be executed in a child thread for this part. And then I use the is model to detect and recognize tests. The with lock ensures flag safe operation in this part. Also, the join function waits for the child thread to complete the test detection task of the is model. And the main thread is the pedal OCR for test detection. Now let's run this file. First, the image that is ready to be detected and recognized is this one. That's for the PNG. Let's have a look. Okay, so now I run this project, run this file, and then we see the results that showed in the console. Okay, it's done. So first, this one, the pedal OCR detection and recognition. This is the console. This is the child thread. Use is model and SOH recognition. And see the results. Let's have a look at this one. This one is the after processing image. And this one is for ACE model to detect the test. And this one is the after processing image and for pedal OCR model to detect and recognize the test. I use two different methods to process the image. And this one is the result of pedal OCR model to detect the image. For test detection and recognition using the pedal OCR model, I added a test tag to the test part in the pre-processed image. From the detected image, we can see that the detection success rate of this model is extremely high. Basically, the places where there is a test are found by a bounding box, and the attention is focused on the test file, TST file. The recognized test is stored in this TST file, and also it is not difficult to see that the model has a strong test recognition ability and a high recognition success rate. But in contrast, let's see the results of its model detection. Well, it only just found a little bit of this image. So we can see that the East model is the success rate of detection is very, very low. Also, as we can see, the effect of using the East model for image task detection is not good. This model is not accurate enough in drawing bounding boxes for task areas, which reduce the accuracy of task recognition by tesseract OCR. At the same time, it is obvious that the tesseract OCR is not very effective in task recognition, no matter the Chinese and English. It cannot recognize tasks accurately, and garbled tasks will appear in the Chinese recognition part. Also, we see the results of recognition. This is the result of using Paddle OCR model, but using the IS model, it only detects one test area, which is obviously impossible. But more unbelievable is that the tesseract only recognize one test E, which is also wrong. So we can say that the IS model for task detection and tesseract OCR for task recognition is not good. So let's see the console. Well, I use a double flash in this step and the two flash execute in parallel. So the output results of the two flashes are printed crosswise. I recorded the total execution time of these two methods to compare the efficiency and accuracy of the execution, as it shows in the console. Now let's see the GIF file task detection and recognition. Now let me introduce the GIF file task detection and recognition in this project. But first, let me show a GIF in Python. It's 0019.gif. Let me run this file. Okay, this GIF is like this. A man is shouting what? Okay. So let's run this GIF file task detection and recognition. Okay, I run this file. See the result in the console. Yeah. And wait. And the test output is in this one. This is the frame one for task recognizing what. This, this is the total recording file. This is the results in the console. This one is the after preprocessing image in frame one, like this. Okay, and this image is the image that using Paddle OCR model to detect and recognize the text. So in this step, we can see that obviously we can see that I use the Paddle OCR to detect and recognize text in specific frames and printed the results in the console. And the recognized text results are stored in this recognized text.txt file. Preprocessing, yeah, the preprocess, okay. In this step, I defined, no. The image preprocessing includes Gary scale conversion, this one, okay. And adaptive thresholding, this one. Also, the bilateral filtering, this one, to remove the noise of the image. And for Paddle OCR detection and recognition, and this one, this file, okay. The main point is the task identify task function, this one, okay, this one, yeah. And in this function, it performs OCR detection and recognition on the input image, and it turns the recognized tags, bounding balls, and confidence. Yeah. Through the OCR.OCR method, this one, okay. The Paddle OCR performs task recognition and extracts bounding balls information, task content, and confidence. Okay, this is the function, some text. Okay. For the IS model and tesseract OCR, I use the detect task is function, this one, to detect task areas in the image, and using the IS model and output the bounding box of, and then use the tesseract OCR function to call tesseract for OCR recognition for each task area detected by it, and export simplified Chinese, traditional Chinese, and English. Let me see this function. Okay, in this part. Okay, this part is to use the tesseract to recognize the tests. Okay. Last, let me to do the GIF detection and recognition. Okay. First, it also preprocess the image. Okay, using the Gary scale bilateral filter and adaptive threshold. Okay, and then I use the extract frames from GIF function. This one. Okay, so extract all frames of a GIF file, and then I use the filter duplicate frames function to filter out duplicate frames by inner frame similarity to avoid unnecessary repeated processing. Then the OCR on frame function, this one. Okay, this one. This function is to use the petal OCR to detect and recognize text on each frame. Also, it draws a text box on the image, saving the recognized text to a separate text file. Okay. So let me try more samples for the static image text detection and GIF file text detection. So first, let me try this one. Okay, this one. Let me open this photo test main.py, and I just need to change the image path to 020551. Okay, 51. Let's run this file. Okay, as we can see, the console, the petal OCR always detect the correct read, and the success rate is always high. But for the ease model and tesseract, what can I say? So let's see the petal detected. This is the petal detected image. Okay, we can see that the task area is successfully be detected. And let's see the eighth model. I don't know why it detects its eyes. How strange. Okay, this is the preprocessed image for its model, and this is for the pedal OCR model. Okay, let's see the test.txt file. Okay, this is the each model, and using the tesseract to recognize the test. It almost we can say it almost won. Okay, and for the pedal OCR, it is all white. Yeah, all white. So let me choose another static image like this one. Okay, like this one, new movie. Okay, and also I changed the image path to WeChat 245. Yeah, yeah, this one. Okay, and run this file. Okay, you can see that the pedal OCR is done, but the east and tesseract is working. Okay, working. Oh, it's done. Let us see the results. This one is the result of pedal OCR detection. Yeah, this one is successfully be detected. And wow, you can see that using the east model to detect the test is not that effective. You can see this one, this one, this one, this one, this one, not test, this one. Okay, and see the results. This is the pedal. The one is new movie. Who is the CTION? Where is the CTION? It's in this CTION. Okay, and for the east, wow, I don't understand. Okay, let me pass another GIF. Okay, using this one. Subscribe. Okay, using this one, and I change the image path, GIF file path. Oh no, and this one, okay, in this file. And I changed this one, GIF path, okay, to subscribe, and run this file, okay, run this file. So it gives 2 frames to detect the test and recognize the test. And in the frame 1, okay, in the frame 1, it detects and recognizes successfully, okay, subscribe, and see the results. This one is the task detection for frame 1. Okay, it successfully detected the subscribe. Yeah, and this one is the preprocessed image after preprocessing. Okay, this is the task result subscribe. Okay, subscribe. This is the total test. In the frame 1, you recognize the subscribe. Okay, and I use another this one. Okay, this one. Also, I changed the give path to this. Okay, so I run the file. Okay, it's also detached in frame 1. One is always, another is this. Okay, another is this. And the preprocessed image. After preprocessing image is this. Okay, and yes, it also the petals are detached successfully. For the result, yeah, always. And this one, and the total, yeah, in frame 1. Okay, so this is the whole information about this task, a static image task detection and recognition, and GIF path task detection and recognition.